For more videos, visit forthesakeofeducation.com. Alright guys, let's do this problem where they want you to find the normal force, shear force, and moment at section passing through point C right here. So as you can see right here at A, you're gonna have a pin, so you have a vertical and horizontal reaction. Let's call it AY and AX. As you can see here, you have this force P, and they tell you P is equal to 8 kilonewtons, and we have this tension right here being developed by this cable. Let's call it T for the tension. So the first thing we're gonna do is we're gonna find T. So we're gonna assume that the going clockwise is positive for the sum of the moments at A, and all these moments come out to be 0 because this is statics. So the moment being created by T, on the first chapter you learn how to calculate it. You gotta calculate the distance between here and A, because this is where T points, and this distance is given by 0.5 meters plus 0.1 meters, which is the radius of this wheel. So T times 0.6 meters minus the moment being created by P, which is P times the distance from P to A, which is 0.75 times 3, which is 2.25, right? Yeah, 2.25, and it is equal to 0. So when you solve for T, because you already have P at 8 kilonewtons, you get that T is equal to 30 kilonewtons. Now that you have T, you can find AX and AY, because you know that the sum of the moments, sum of the forces at X is equal to 0. So the forces in the X are T minus AX equal to 0, so AX is equal to 30 kilonewtons. That's the reaction at A. Now we also know that the sum of the forces on the Y is equal to 0, and we can use this to find the reaction AY. So P is going down, minus P plus AY is equal to 0. So AY is equal to P, which is 8 kilonewtons. So now we got AY and P. So now we're going to use the method of sections, to find our shear, moment, and normal. We're going to use this section right here. So let me redraw that section right here. This is C. The normal is obviously going to the left, because you know that we have here AX and we got here AY, so this will be the normal. The shear will be coming down, and the moment, let's say the moment is going this way. So we got AX at 30 kilonewtons and we got AY at 8 kilonewtons. So sum of the forces on the X is equal to 0, so you know that the normal minus AX is equal to 0, so the normal comes out to be 30 kilonewtons. Sum of the forces on the Y is equal to 0. In the Y we got the shear coming down, but we got AY coming up, and that is equal to 0. So the shear is equal to 8 kilonewtons. And assuming clockwise is positive, sum of the moments at C is equal to 0. So MC minus the moment created by AY, which is AY times 0.75, because from C to A is 0.75 meters. And you know AX creates no moment because it points directly at C. So sum of the moments is equal to 0, so the moment is equal to AY times 0.75, which comes out to be 6 kilonewton meters going clockwise. So final answer for the normal, final answer for the shear, and final answer for the moment at C.
Please comment below if you want me to do any problems and I'll be happy to help. Thank you.